look here. Uh, if you are going for the first question, this one. So here keyword is core becomes magnetized. Okay, this is keyword. Is it clear?
Means how is not important. It become magnetized. That is important.
Yeah, yeah. Then if it is magnetized, uh, then iron armature will be attracted to core, right? Iron is magnetic material, that's why it will be attracted to core. So you will just bring this idea that iron armature is attracted. Okay, then contact touch or switch is on, right? This one, your contact touch, and this motor is working then. Is it
Yes, sir.
clear? Okay, Karim,
Yes, sir.
you understand now the keywords?
Yes, sir.
Okay, now your mistakes. From your mistakes, you have any confusion? That one you tell me.
No, sir.
Here I did one mistake, typing mistake. You understand my typing mistake?
Sir, I just need to understand the question. So typos are just a small thing.
Yeah. So typos are small things here. It was 6, now it became 5. That's why your score is no more 21. It is now 20.
Uh, Out of 29.
30, 30 out of 30.
Sir, this is not fair, sir.
Like here, I wrote 6. It was typo. Is it clear now?
Sir, these types of typos are really bad.
Now you are thinking that typos is important, right? Okay,
Yes, sir.
now look, this part you did, you got 1, right? You lost 1. So did you understand this feedback?
Not quite well, sir.
So they are asking why current is produced in C1. So always we are saying it that the current is produced, lines of magnetic field line uh, cut the coil, right? This one you have to bring, then we are having induced EMF produced in the compressor. So what you wrote? As a
Sir,
charge,
once again, my earphone is giving some disturb. I need to change it. Just 1 minute.
yeah.
Sir,
Yes, yes.
sir, one more minute, sir. Yes, sir.
So look at the question. Explain why current is produced in C1. C1 means this one, right?
Question.
Yeah. Describe how a permanent magnet is used to produce a large reading on the ammeter. So you got here the magnetic field lines are cut, right? Cut by
Yes,
the
sir.
magnetic field lines are cut by the coil, and that's why there is induced EMF.
Yes,
So,
sir. I just use stronger magnet so that the density of the means magnetic
but
flux
what
become
you
more and
wrote here, the charge in the wire is attracted or repelled by the magnetic field. Can charge be attracted or repelled by the magnetic field?
no, sir.
It's not, you know, any sense making. It's totally incorrect concept. So then, what we have, they keep moving, and we call it induced EMF. Only for this wording, induced EMF you brought. That's why we could give you 1 mark. Okay, we should bring this idea. Magnetic field lines are cut by the coil. Then this part you wrote from negative to positive terminal. When
Yes, sir.
they are asking you about the what will be the current direction in the circuit. Current direction always from positive to negative, right?
But sir, isn't it conventional current?
If they are saying current flow, current direction, you should without any thinking, you should consider it as conventional current flow. Is it clear? For current flow, we are always using conventional current flow direction.
Yes, sir.
Then here you lost again another mark. Uh, what you wrote? Explain why the copper wire moves along the copper rod. So here you got copper wire moves due to Fleming's left hand rule, right?
Yes, sir.
Wrote that. For that you are getting 1 mark. But how the Fleming's left hand rule is working, in that case you did wrong. You just wrote due to conventional current, the motion of the copper wire is decided according to Fleming's left hand rule. They are saying why the copper wire moves along the copper rod. So they did not ask you how the copper wire moves. Is it clear to you?
Yes, sir.
But your answer, the first part, you are representing in a way that you are answering how. and also it's inappropriate. Yeah, they they are asking you why the copper wire moves along the copper rods. Copper wire is moving due to some forces, right? And
Yes, sir.
that force is coming from magnetic field, right? And the
Yes, sir.
current producing. The current is going and the magnetic field is there. That's why there is force created according to Fleming's left hand rule, isn't it? So
Yes, sir.
we have our first finger for magnetic field, we have our second finger for the current, and these two are combinedly making Fleming's left hand rule. We have another one, that is thumb. Thumb is showing you the force, right?
Yes, sir.
So here you have to mention this one, current and magnetic field create a force. Okay?
Means an indication to that first point that current and magnetic field creates a force.
Yeah. But your what you said, the copper wire is decided according to Fleming's left hand rule. What decided? Motion of the copper wire, right? Then you are saying how,
Yes, sir.
but why is created? That one you did not bring. Okay?
Yes, sir.
Why? The answer should be current and magnetic field created force. That's why. Then next one is calculate, name two different devices those use this effect. So here you wrote DC motor. That is correct. But AC generator is not. AC generator is not using Fleming's left hand rule.
A generator means right hand rule.
Yeah, generator is using right hand rule, and in generator you will never get motor effect, that force from the electricity. Rather, you will get electricity from the motion. Is it clear?
Yes, sir.
So you gave two examples from two sides, right? DC motor is okay, but AC generator is not working properly here, right? It should not be here.
It should also have been AC motor, right?
AC motor is there, and if you are using AC motor, then there is slip rings. Okay,
Yes, sir.
so you can bring that one, but they are simply asking you where we are using this DC motor or Fleming's left hand rule, where will you use. Is it clear? The
Yes,
first
sir.
one I gave you a look, electric motor or any device that contains electric motor. Second one is loudspeaker or any device that contains a loudspeaker. Okay, so you can try it, huh?
Yes, sir.
Here, then is particularly asking you about transformer, right?
Yes, sir.
So how this iron core is, uh, you know, applying the role in making the transformer or the activity of transformer. You see here we have, you wrote, it is a soft magnetic material. State one other purposes of using iron core. They are saying to write the purposes. You are writing the property.
Sir, it is a purpose because the transfer is normally that the primary and the secondary coil are fixed. So if the magnetic field lines don't change, so they won't be cut. And so the
Listen. I clearly told you it's the property of iron. It's not purpose. And is particularly asking you about transformer. What is the purpose of using iron core in transformer? It's very important. It's not like uh, you will say superficially and it will be correct. We are using in transformer, we are using alternating current, right? Isn't it? Hello.
yes, sir.
So alternating current you are using, and you are using iron core there. So there is some purpose to get the changing magnetic field, right?
Yes, sir.
So changing magnetic field, if there is not, then what is the use of transformer? Why we are using this one extra device? It is the function of transformer. Right? Soft magnetic material we are using in many places. Many places we are using soft magnetic material, but is
To
particularly asking
increase or
about,
decrease the amount
yeah,
of,
is particularly asking about transformer. Why we are using this? So in the transformer we are getting two coils, right? Primary, secondary, right?
yes, sir.
Isn't it? So what this iron core is doing is helping the primary to get change in magnetic field so that it can induce EMF in the secondary, right? Karim?
Mm, sir, didn't understand. Can you just repeat once again?
Yeah, you have written, right? You have written on your copy about transformer lots of things. Can you read them for me?
1 minute, sir.
Yeah.
Yes, sir.
Yeah, what you got at the beginning about transformer? You got any idea about changing magnetic field?
Yes, sir. At the primary coil, the applied alternative voltage sets up a charging magnetic field, which is an EMF in the secondary coil. A setup transformer is one where the EMF in the secondary coil is generated than the EMF in the primary coil.
So you got it now, right? What is the use of transformer?
I think I didn't hear.
You got the idea now. What is the use of transformer, or how the transformer is working?
Yes, sir.
So there we get there we get changing magnetic field in the primary, right? Isn't it?
Yes, sir.
So this changing magnetic field we are getting because of alternating voltage, right?
Yes, sir.
So this changing magnetic field is helping us to get induced EMF in the secondary, right?
Sir,
Yeah.
like this is our iron core. This is primary coil. This is secondary coil.
Hmm.
If this thing is means iron, but uh, means just for means whatever we are discussing, it is only for the property that it is a soft magnetic material.
Hmm.
So it is a purpose for us. But if we use have steel, which is alloy of not alloy, yes, alloy of iron. So on that time we wouldn't have been able to get it. So shouldn't we just take it as one of the need for it?
Yeah, it is property. I told you it is property, but it is not the purpose. Our purpose is to change the field, right? From
Magnetic
from
field.
yeah, from primary to secondary we are shifting the EMF, right?
Oh, so
Is it clear
means
now?
yes, sir.
That
Understood.
is our purpose. Without this we cannot use transformer. Okay, is it clear? So it's simply you are saying soft magnetic material. That's not enough. It is not the purpose. We have this property in iron, but what is the target of it?
So if I would have just write and extended a bit that it allows the mm, it allows the core to change magnetic field when alternative current is passed.
Hmm.
So it would have been correct.
Yeah, so then it is transferring its voltage to secondary, right? Because magnetic field lines are cut in the secondary. You need not to explain that much, but you have to mention at least that from primary to secondary, the voltage is transferred, or the EMF is transferred, or the field is transferred. This way you should mention. Okay, is it clear?
Yes, sir.
Okay, then it's done now. 3B is done. 3C. 3C you got here 0. Yeah, so here you will describe briefly how an output voltage is used in coil B. So where is coil B? Here. Coil B is here giving supply to our house.
It is cutting the magnetic field lines and is creating the magnetic field lines.
Yeah. So here it is number of turns less or more at B.
Less.
Less. Very good. So what is the use of this less number of turns? To step
Step
down.
down.
To step down, or you get less voltage than the uh, power supply,
Primary.
or primary, whatever you say. So this one you have to bring here, your idea. Look, we are having changing. This change we are having, why? There is changing magnetic field, right? From primary to secondary, we are getting the lower voltage. Why? Because of the changing magnetic field, or field lines are cut by the coil. That's why. But what you wrote here, the end of the coil are connected to a wire which have its end to houses or other usable appliances so that we can use it. So it's not saying how the output voltage is used. You are writing lots of literature, but the key points you are not giving.
So I yet still didn't get the question.
Yeah. You have the question? Hello? Hello? Karim? 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 Hello? Karim? The microphone. That's why I stopped the recording for a while. Because
Oh,
it's wastage of time, right?
yes, sir.
When someone is watching it, it's wastage of time if there is no recording. So this is done. This is done. Now this one, right?
Yes, sir.
Okay. So here you wrote suggest one advantage and one disadvantage of burying a power line underground rather than having an overhead power line. So they are asking you the advantage of underground. They are asking,
Advantage of underground.
yeah, they are asking you about disadvantage of underground. But you wrote
And
it,
I wrote it upside down.
yeah, wrote it wrongly. And uh, now you can understand by the sentence.
Sir, you
You
should
will,
have also give me marks upside down.
yeah, you will find it that your understanding of this sentence is wrong, right? Isn't it?
Yes, sir.
So this time you were in hurry, or
Yes, sir, actually.
you were maybe because of those uploads. You were a little bit
Yes,
annoyed
sir. They
also.
took a lot of time.
Yeah, you were a little bit annoyed also. Then you did not
I'm not annoyed
display.
actually.
You
Actually, they took me a total of
you
three
became
minutes
you became bored.
for each.
You became bored to spend time more in test. You just gave up.
Actually, what was it that I just need to mark it, and in the above one where I need to show magnetic fields on the coil, it was being very difficult as it was going a lot near and near. So I was just like getting angry that why can't I just give it a single straight line? So for that it took me a while, and the PDF was really slow, the formation of PDF, and after that generating link it just took time, and then uploading was another hassle because the net speed, I think it was a bit slow on that time. Sir, can you hear me?
Yes, I got you, and it's clear to me that it was your understanding. You you were a little bit tired also, right? That time after
Yes, sir.
going and trying. That's why you did not spend that much time in some of the questions. So here you got you see they already gave you stronger magnet. Ah, they already gave you stronger magnet. Then they are asking state one other way of producing a larger reading on the voltmeter.
And that would be motion.
Yeah, so
And which I did
Yeah,
in.
you gave the same thing the question paper is giving you, but they are asking you other way.
It is like they are asking me what is x, and I wrote x is equal to x.
Yes. So it's happening in your life, right?
Yes, sir.
Now I'm sending you the. I think you got the same score now. 21 should be this one because one mark decreased in one place, another is increased. Then sum
Yes,
is
sir.
still here. You see now it's 24. You know it's Tamjit's one. Yeah. So why are we looking at your script or Tamjit's script?
I think we were looking at his one.
Let us check again.
No, I think we were looking at mine.
No,
Okay, we
yes.
were looking at his one.
Yeah, yeah. This one we are looking his one. It was correct for your one. Now this one is correct also.
So we are totally solving his one.
Yes, yes, yes. But you are not saying anything.
Okay, sir, I was right here.
Yes, here you are right.
Oh, so I think we should look above a bit more. I think I will find. Yes, sir. I think one more. Yes.
Yeah, till here it was okay. Then here you got mark, right?
Yes, sir.
Here you lost.
Actually, I write a lot big.
Mhm.
He also wrote like me that advantage this and disadvantage this. It was a weird one. Yeah. Okay, we wrote the same thing.
Mhm. So done.
Sir, what was my mistake over there on the
Which
formatted
was
one? Yes, sir, this
this
one.
one.
Yes, sir, what was my
This
mistake?
one you did a very simple thing you did wrong. Look, they are saying
Sir,
the
can you show?
direction of the current. So you should use right hand rule, right? Fleming's right hand rule.
Yes, sir.
Now they are saying, uh, oh no, here we have power supply. Power supply we have. So
Yes, sir.
we
We should
should be
take conventional current rather
yeah,
than
we should
electron
use
flow.
here Fleming's left hand rule if you have the power supply. So let us check, huh? The direction of the current uh, label this current C. So positive to negative. It should be this way towards the right side, isn't it?
I gave the opposite one, the flow of electron one.
Yeah, flow of electron on in here. Let's see.
Yes, sir, I told you.
So this way you did wrong. Your magnetic field is correct. The other two are wrong. That's why. Is it clear?
If we would have used the flaming left-hand rule, then in one of them,
Mhm.
the force, it would have been gone downwards.
Mhm. So got it right.
Yes, sir.
And the feedback is there. you can take the feedback. The feedback we also gave. Okay, now we check your score again, right? It should be
Sir, there
20.
was a mistake in one. I think we didn't solve it.
21, yes. I told you 21. Huh?
No,
Which
sir.
one?
Sir, in one, there was a mistake.
Which one?
Sir, I think it's more bit lower. Means I just saw
Okay, okay.
a
I'm
bit more.
showing you, no problem.
Yeah,
This one?
here, yes, sir. Here.
Okay. This one we discussed.
Sir, did we wrote the same thing again?
Yeah, this one we discussed. This is okay.
No, sir, because in Tamjeev's one, it was just same, ditto.
No, no, no. That one was not Tamji's one. Your one
Mine
changed
one is mine.
afterwards. Your one changed afterwards when you were, re.
Correcting the,
Yeah.
recorrecting the,
Till here, I said that this was okay. We discussed. Hmm. Till the DC motor, it was fine.
yes, sir.
Yeah, but later on it changed somehow. Okay, so it is done, right?
Sir, in 3B1, I think I should, means I would have a deduction in mark because according to the question, I didn't wrote the answer what it was supposed to be.
3B.
3B1, I guess. 3C, 3B, yes, so 3B, 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 lower, 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 lower. One more. Yes, sir, here in the induced one. Because they said
3C,
use and
3C.
yes, sir, because they said used and I wrote the induced.
No, the question was used, they wrote, but later on I corrected it. Okay,
Oh,
so this one, that's why I gave you mark.
yes, sir. I thought that means this one wrote Tamjid wrote, so means
No, no,
just
Tamil
due to
wrote this
that,
one.
just due to that one changing in question, it made a lot of confusion.
Yeah, yeah. I agree with you about that one. That one is resolved, right?
Yes, sir.
Now we can go for our next meeting, right? Our
Yes, sir.
meeting is over after 6 minutes you join, huh? Okay.
Okay, sir.